Okay, lesson 9.2, series and convergence. So if a sequence is the listing of the terms, then the series is the sum of the terms of an infinite sequence. Now remember how sequence was defined. It was just defined as a function whose domain were your positive integers. So this is just a screenshot right from the text. Okay, if n is 1, a sub 1 would be the output. When n is 2, a sub 2 was the output. The output are not positive integers, just the input. So the infinite series, notice we reintroduce our summation notation. So from our index n is equal to 1 to infinity, the sum of the sequence is we literally add the terms together. Now to find the sum of an infinite series, look at the sequence of partial sums. Okay, so let's look at our different notation here. A sub 1 would be the first term. Let me put that here. A sub 1 is the term, but S sub 1, this notation is the first partial sum. So the first partial sum would always just be equal to the first term of the sequence. Then the second partial sum, I add the first two terms of the sequence. The third partial sum, we add the first three. And to the nth, this is our nth partial sum. And this is important when we're determining the convergence or divergence of a series. Okay, if the sequence of partial sums converges to S, then the series itself converges. Whatever this limit is called, the limit S would be the sum of the series. So notice the difference. S sub n is, they're the partial sums, plus a sub n. The limit of those partial sums, if that exists, that's what the sum of the series would be. If the sum of the series diverges, then the series itself diverges. So that makes sense. But you have to understand it's different than finding the convergence or divergence of a sequence. A sequence can converge to a given value, but the same series can converge to another value, and we'll look at that now. All right, so pause the slide. Given the sequence defined by 1 divided by 2 to the n, list the first 5 terms of the sequence and determine if the sequence converges or diverges for me. All right, pause that, and I'll check these tomorrow. Okay, now we're going to find the partial sums for the series. So part A, list the first 5 partial sums. So the first sum is just equal to the first term. Okay, S sub 2 would be S sub 1, which is really A sub 1, plus A sub 2. So the second partial sum would be 3/4. The third partial sum, I could take my second partial sum and just add to that the third term. Okay, because we're always just taking the previous answer. So that would be 7/8. My fourth partial sum, I take my third partial sum and add to that S sub 4. So that would be 1/16. This would be 15/16. And lastly, my fifth partial sum, I take my sum from above and I just add to that my fifth term, so 1/32. And this would be 31/32. So the actual answers are the partial sums. Okay, so for space, let's look at B here, then we'll do C on the next slide. Now find the nth partial sum for the series. Now this is where it's different. To list the terms of the sequence, we use this, 1/2 to the n. We plugged in our positive integers, we listed the terms. the partial sums, we then took those terms and added them together. But now what you're doing is you're attempting to find, okay, what's a formula, what's an equation to find those values? That would give me the nth partial sum. So looking to the bottom is still 2 to the n, okay? S sub n, so the fifth partial sum, 2 to the fifth would give me my 32. Now look to the numerator here. Well, the numerator on each of the partial sums is just 1 less than the denominator. So I have 2 to the n minus 1. Look at the difference here. This is the terms of my sequence, 1 over 2 to the n. But then when I start adding them together, it's a different function. So the sum of the nth terms is 2 to the n minus 1, all divided by 2n. All right, so using that answer from part B, sum of n terms, 2 to the n minus 1. All right, now to answer C, determine if the series converges or diverges. So now if I find the limit of the series, that's the limit as n approaches infinity of 2 to the n minus 1 all over 2 to the n. We can do a couple things here. You can look at L'Hopital's. You can think of it as sort of being equal, but I only like that with the degree. If we break this up, right, 2 to the n divided by 2 to the n minus 1 over 2 to the n. This simplifies to 1. So this limit will approach 1, that limit would approach 0. So the series converges, and the sum is 1. All right, let's check out another one. Given the infinite series below, list the first 3 terms of the series. Okay, so pause. List the first 3 terms of the series here for me. Take note, when n equals 1, you have to plug 1 into each fraction. And then you're going to add to that when n is equal to 2. And then you're going to add to that when n is equal to 3. Okay, so hopefully this is what you got for your first 3 terms of the series when n is equal to 1. N is equal to 2, n is equal to 3. Now let's attempt to determine the nth partial sum of the series. Okay, so if we sort of reorganize this and move the parentheses a little bit, I can have 1 plus negative half plus positive half. And I'm actually going to write that as 1 minus negative half plus positive half. And you'll see why. But I'm going to take that negative sign here. So if I'm just factoring out the negative, then this would be, hold on. If that, okay, sorry. So it'd be 1 minus a half minus, minus, if I look at this again, a third minus a third. And then I'm going to subtract from that a fourth, and then what would follow that? It would be another fourth, okay, so forth and so on. So now what you're seeing here, notice that all of these terms, all of their sums are going to be 0. So the nth partial sum, I have my 1. The 1's not going to cancel with anything. Now, what's the formula for this here? This is just your 1 over n plus 1. Okay, so the nth partial sum would always give me just 1 minus whatever it is I'm looking for here, because all of these will cancel each other out, everything in between there. All right, so if that's the nth partial sum, determine if the series converges or diverges. If it converges, find the sum. So the limit as n approaches infinity. Okay, that limit approaches 0. Limit exists, it converges, and the value of the limit is the sum of the infinite series. Okay, the last thing I'm going to leave you with, just to copy these notes down, a telescoping series is one where you notice that the second term will cancel with the third term, so that negative b sub 2 plus b sub 2, and then b sub 3 would be canceled by the third term, and this pattern will continue. So the nth partial sum will always be whatever the first term is minus what that b sub n plus 1, how we get our next term there. The series converges if and only if, okay, b sub n approaches a finite number as n gets infinitely larger. And if the series converges, then the sum will be the first term minus whatever the limit of that b sub n plus 1 is. So just have this in your note, this slide in your notes for me, and we'll continue with this in class.